we would have had Kenneth. Kenneth works for the Ministry of Environment, Forestry and Tourism as Head of Wildlife Research and Monitoring in the Directorate of Scientific Services. You all know him well. He's a keen member of Scientific Society. He has a master's degree in environmental management from the University of the Free State in South Africa and has diverse research interests in the field of wildlife ecology, community-based natural resource management, protected area management, and financing hybridization. How do you pronounce that funny English word? Okay. So then we have Colin Craig. You'll see him just now. Colin's 40 years of wildlife management planning, ecology, research, and conservation in Africa began in the national parks in Zimbabwe, where he became a chief ecologist. And I wonder whether it was not Rhodesia, but anyway, let's keep it Zimbabwe. In Botswana, he designed and established a system of countrywide aerial surveys of wildlife. And from there came to Namibia. I hope you say Namibia is the best. So just for my comment, after 4 years as a chief conservation scientist in MET, he has spent 20 years as a wildlife consultant working mainly on aerial surveys in Mozambique and Namibia. Colin is an active member of the IUCN African Elephant Specialist Group. So there you really have an expert. Thank you for coming, Colin. And then we have Debbie, as I know her, Deborah Gibson. She was a principal ecologist in Zimbabwe's Department of National Park, where her research focused on monitoring and aerial surveys for 9 years. As a freelance consultant for 28 years, she has undertaken a variety of conservation work with emphasis on establishing monitoring systems and conducting aerial surveys of wildlife in Southern and West Africa. She is an active member of the IUCN African Elephant Specialist Group. So there you got some more experts around. And with this, I hand over to Colin, and you all please enjoy.
Is that okay? Okay. So this is the background that was going to be presented by Kenneth. I used to do his job, probably not as well, but I shouldn't really be here speaking for MEFT, but here I am. So we'll just give us a quick background to that. There's recently been a lot of concern about the decline of elephants. What happened? Which is the off? Which one must I not touch?
This one is making it dark.
Ah, right. Okay. And numbers are declining because of habitat reduction, illegal hunting. 2/3 of range states that contain the savanna elephant have had populations that have declined since 1940. That's 2/3. But most of the ones that have not declined are in Southern Africa, and one of those is Namibia. So Namibia is a bit of a success story. And aside here, is why I'm talking about savanna elephants, is that just recently the species, the African elephant, has been separated into 2 species, the forest elephant and the savanna elephant. All of Namibia's elephants are savanna elephants. The forest elephant occurs in equatorial Africa and West Africa. Savanna elephant occurs in Southern Africa, East Africa, and around the Sahel part of Western Africa. 75% of the continent's population of savanna elephants, and that population is about 400,000, 75% are now found in Southern Africa. And that includes Namibia, of course, where numbers seem to have been increasing for at least the past 25 years and probably for the past 100 years. But we can be certain about recent increase. And this needs to be known internationally, because internationally, people think the elephant's going extinct. It's far from that. Conservation issues, all those, the usual suspects. Okay, Namibia's vision. This is from the management plan. Namibia's elephants are not being managed for growth. So we're not trying to get the population higher, apparently. And neither are we managing them for a constant number. We're not trying to control the numbers. What? Oh. We're not trying to control the numbers. But nevertheless, when the numbers are increasing, evidence of good protection and good management. Oh, I've done it again. So those are MEFT's objectives. To meet those objectives, monitoring is an essential part. Because we need to track if the management activities are essential. A number of monitoring programs are in place. Aerial surveys are best to get an overview and to check that numbers are not declining. Okay, so that was our introduction. You think those are in Caprivi, don't you? Those are in Mozambique. Next one, please. Next talk. Sorry, we got them separate. No, wrong one. Let's get this finished before the rain comes down. So I'm going to be talking about aerial counts, why we do, how we do them. Oh, just to go back to Kenneth's side again. I mean, the reason that we're involved in this is because Kenneth, since he took up this post, he's been promoting surveys since he's been in that post. And occasionally he's been asking us to help out with surveys. So we've been involved in some of the surveys over the past 10 years. And so we put together this presentation. Have you lost the help? Okay, perfect, thank you. How do we count these things? Again. accuracy is an issue. Obviously, we want to get the right number. To do that, we need to spend enough time searching, make sure all the animals are seen, fly low and slow, not too low and not too slow, but still. And you need to cover the entire range systematically. Spending enough time searching is very important. A standard that we try and adhere to is that each square kilometer needs to have between 1 and 1.5 minutes. No, other way around. If you spend a minute looking, you have searched between 1 and 1.5 square kilometers. And if it's if it's more than that, if you're searching more area within a minute, it's not up to standard. You're going to be missing animals. So we try to adhere to that standard, whatever kind of survey we're doing. And it's probably the most important standard. We want surveys to be comparable from year to year. So we try and use standard methods, standard equipment, standard timing in terms of season. We try and count in the same month of the year. If we counted in October last year, we count in October again this year. If we counted in September last year, same again this year. Then it becomes comparable because animals move around seasonally. So comparability is an important factor. Kinds of aerial surveys are basically two types: total counts and sample counts. I think you know what I'm talking about when I say a total count. Fairly obvious thing. Oh, I've done it again. Easy, because there's no special equipment required except an airplane and a navigation system. You need an airplane that's going to fly slowly like a helicopter or a Piper Cub. You can vary the number of crew and at the end of the day, the analysis is simple. You just what you see is what you get, and you add up the numbers. That's why people like doing total counts. Easy. You think it's easy. I'm no good with this, really. So total counts, we want to look at every square inch of the area. It's intuitively more obvious, but there are drawbacks. To cover a large area is not feasible with a total count because partly because of the cost and the time involved. The example we've given here for Zambezi, we managed to do that in 10 days at a 16% count. But if you go back to that 1.2 square kilometer per minute, it's going to take you 54, I think more like 60 days to count the whole area if you try and total count it. And you can't total count it because the assumption of a total count is you see every animal once and you see no animal twice. Because if you don't see every animal, you've got an undercount. If you see some animals twice, you've got an overcount. And maybe that will average out, but you can't be sure of that. And when you're dealing with a very large area, it's almost impossible to ensure that you can meet those two assumptions, that you see everything and you don't see anything twice. So basically, but my rule of thumb is that you shouldn't total count anything that you can't count in one flight. Between takeoff and touchdown, you can total count an area that's probably about 200 square kilometers. Don't go above that. So because we can't do total counts for big areas, we resort to sample counts. What do we say? Count a representative part of the area. An example here, with a whole area of 2,000 square kilometer, if you search 10% and you see 50 animals, you would estimate there are 500 in the area. That's fairly simple as well, actually. But a bit of calculation involved. So we can get an estimate by doing a representative sample of the whole area. It must be representative. You've got to visit each part of the area, but you don't have to look at every square kilometer. You just, in each area, you take a subsample and you count the elephants in there. Because say you're going to count, say you do see 50, you expect to see 50 elephants on a 10% count of 500. You're not actually going to most of the time. You might see 50. It's likely you'll also might see 51, you might see 49, you might only see 40, because that's random chance, because you are not sampling the whole area. Some of the animals you're going to miss, or well, not miss as such, but the animals might concentrate within your sample, or they might by chance not be in your sample. So the number you see is going to vary around 50, and you have to calculate then what the confidence interval is. That is the range of numbers that we're 95% sure that the real number falls into. And that is what you call a measure of precision. Precision is very important. If you want better precision, you go to a higher sample intensity. So 10% is better than 5%, and 20% is better than 10%. But eventually you become limited by the amount of time or the amount of money you have to spend. And generally, we tend to be aiming at around 10%, a bit more, when we're doing surveys of big areas. And that's just because of the way money is available. Money and time. You know, if it takes a couple of weeks to do Zambezi region, that's still a couple of weeks. And you've got to pay, you've got all the logistics. Surveys become quite expensive. So the amount of precision that you get tends to be limited by your resources. So when you're planning a survey, see, like in the Northwest, you might use a combination of methods. Is there a laser beam on this? Oh, there is, yeah. But actually, we probably got titles here. See, we total counted along the rivers because there's a quite relatively small areas that you can do in one flight. And elephants tend to concentrate there. So you can get a jump ahead of your precision if you know where elephants are. Then where there's mountains and you can't fly straight lines, you do block counts. We'll see in a minute what a block count looks like. That's a sample, a different kind of sample. And then on the flat ground, you fly transects. And that's easy, and it's easy to plan. but you cannot fly transects with the mountains because you can't fly up a mountain in a straight line. Now we'll look at the actual track logs, zoom in on that, and you see what happens in a what happens in a block count. The aircraft flies from block to block and it covers the whole block and sees everything within that block. So now your blocks become a sample. And you can see the way those are arranged, it's 25%. That's one of the highest samples we ever do. The 25% sample in a block count. This one's a bit, just round over the edge here, we've done a low sample of 5%, probably too low. And then in this area, I think these are 10%. The line spaced at about 4 kilometers. And the aircraft flies up and down these lines, and we'll see in a minute how we count on a transect count. Well, we got a crew, an airplane with high wings. We have a good pilot from West Air usually. We've got a recorder who sits in the front with the pilot, and we've got 2 observers who sit behind the pilot. We've got a ground crew. It's not fair to say they're dogs' bodies, because actually on the ground tasks, everybody mucks in, especially with refueling. You basically have a small crew of 4 people with each airplane, plus somebody to back them up on the ground. The equipment that you have, you need that high wing airplane. Markers on the struts. Now that's very important because the observer who's sitting in the back seat looks between those markers and counts all the animals, elephants, and everything else he sees between the markers. And because you're flying at a constant height on the ground, those markers represent a constant width. So in each transect, you're taking a big swath of ground and you're counting all the elephants in it. And same on the other side of the aircraft. And that is your sample. So at the end of the day, you know the area you've covered and you know the number of elephants in it. So you know the density of elephants and you know the total area that you've sampled from. And therefore you've got an estimate of the number of elephants and a bit of a confidence interval as well. Okay, so that's got laser altimeter. You've got an application that runs the laser altimeter and tells you how high you are. We used to have radar altimeters. Actually, I prefer them, but nowadays we're going a bit cheap, and the laser altimeters are good because you can record the height. You don't have to write it down. We never had a method of recording height on. You have to record height because you need to know the height that you were at in order to know the width of that strip there that I showed you. Okay. And you have a handheld GPS, so with the thumb you can just record the position of each sighting you make. The handheld GPS also records the track log, where you've flown. On the previous slide, those tracks, those were recorded on the GPS, and the altimeter also actually records your track. So how that would, the pilot's navigating along the transect, heights maintained using that laser altimeter. The flight logger is displaying the height. There he is, flying along his transect. And that straight line down his navigation system. That's the transect he's flying on. So he mustn't go left or right of that line. And then he keeps his eye on that number and makes sure he's as close to 300 feet as he can stay. And then the sucker in the right-hand seat records all the data. We're still talking about transit counts. These these rods are actually parallel, but there's something about the perspective of that photo that makes them look like they're not. And basically, you these two observers in the back are looking out through those rods and they're counting the animals. And you see the rods indicate which animals are in and which animals are out. And they call both. And it's written down on the data sheets by the guy on the left, who in that case is me, and then the pilot's doing the real job on the right. Pilot's main job is safety. And then we have outputs. That's not the whole outputs. All those species and attributes might be recorded during a survey. It's all useful information. And then for each one, we get an estimate and a 95% confidence interval. And actually, the output also gives you the number you actually saw, the number you saw that were not in the sample and outside, and the density. But we couldn't fit all that on this screen. So we get estimates of elephants plus elephant carcasses, all the wild large mammals, some birds, ostriches, cranes, that sort of thing, crocodiles, domestic livestock, anything to do with humans, because anything to do with humans, you can map that out and you can see the areas that are not too friendly for wildlife. Outputs, other outputs. Obviously, we get on that GPS, we're recording each sighting where we saw it. So there you are in Khaudum and surrounds. That's where we saw elephants on that occasion. And that's where we saw them in Zambezi. Now, just to improve on that a bit, we might optionally convert that to a density map. And you can see because you've got different sampling intensities, just looking at the points, it gives you a slightly biased estimate of where they are, but we can correct for that and make a density map so we can see where the high densities are. In Zambezi, you can see there on the Khaudum and here on the what? On the Okavango, sorry. And there's the Zambezi. And this is the Chobe. And it's quite difficult doing these maps. Sometimes the colors seem to run into each other. It looks really good on the computer, and then it doesn't look so good later. These are high densities. The average density in that area is about 2 per square kilometer in the dry season. It's a very high density. In this area, it's less dense overall, but you see there's some high density points that the survey information picks out. So you also get that information from surveys. If you get enough surveys in a series that give enough comparable estimates, you can show population trends. That's Zambezi. And the line curves up like that because we fit an exponential curve. It's the easiest one to fit. And with biological entities, it's the only one usually that's justifiable unless you have a really large amount of information. These limits here are the confidence interval for the particular survey. And then these red lines here, between these red lines are the true numbers at any date. So this is the confidence interval of the line. And then we have an equation that goes with that line. This one's saying that the population is increasing at approaching 5%. Okay, so that's what we get from surveys. So thanks for that. I'll introduce Debbie now, and she'll tell us some more of the results. Thank you. Huh? Oh. Somebody help Debbie with this machine.
Can you take my muzzle? Thank you. Thanks. It's going to go in back pocket, right?
Sorry for touching you, miss.
No, it's okay. Sorry. Okay. It hooked. Okay, which is the one that Colin switches off with?
Yeah, this is the click. That's the one not to press.
Okay. Good evening. So Colin's told us how the surveys are done, and my job is to tell you, oh, thank you, tell you something about what we do with the results of the surveys. Unfortunately, we used up all the photographs on the first two talks. So there's going to be no nice pictures of elephants, but I'll give you some nice pictures of some graphs instead, which might put you all to sleep. Okay, the first thing is to try and get this to work. Namibia's elephant history, like African elephants everywhere, is kind of bleak. In the very long distant past, there were probably all over Namibia, wherever there was water, wherever there was surface water, but ivory poaching and ivory hunting have caused a huge decline, particularly in the 19th century when there was hunting all over Africa. They really decimated. In fact, that's probably the wrong word. I never know those ones. The numbers. And then, of course, with independence, there was poaching and the numbers continued to decline. But gradually with control, there has been an increase. Elephants were probably found as far, there is evidence that elephants were found in as far down as the Kwiseb. There are tracks that have been dated to 17th century that have been seen quite recently. So they were as far south as that, and there's Bushman paintings all over the country. So people knew about elephants probably all over the country. This is the home range now of elephants in Namibia, if I can get it to work. The northwest, that's the biggest area. As you'll see when I show you the figures, it's not the biggest number. Then there's the Etosha area. There's the Mangeti National Park. There's a small area of northern Kavango. There's Khaudum, Nyae, and then there's the Zambezi. It's stopped working. Oh, no, it hasn't. These are the actual figures, which is kind of boring, but it'll give you an idea of how the densities are varied. The northwest has obviously got the hugest area, but very few animals in them, so they're very not dense. Whereas in Zambezi, which is also a big area, but not as big, they get up as much as 1.2 on average in the Zambezi. Mangeti and Kavango, I've said that these are a summary of data from surveys, but actually we haven't surveyed Mangeti or northern Kavango. Those are from other information like tracking and personal information from people who know stuff on the ground. So the total population for Namibia at the moment is around 24,000 elephants. That's from the entire country, and it's only in the north. There have been a few elephants, as you probably heard. There was one went to Swakopmund, and I think there was one went to somewhere near, what's it called, Akahanya. But those are just sort of loonies that have gone AWOL for a while. So here are the graphs that are generated by the data that we've got. These, I've actually got this, the next slide should be before this one, sorry about that. But this is showing that there is, despite the fact that there's quite a variation in parts of the country, there is a significant upward trend of elephants in the country since the early 90s, well, mid-90s. It's 5.4%, and that is statistically significant. And you know that Colin described those red lines, that those lines are indicating that the increase is between 4 and 6%, 4 and 7%. 5% is quite an average sort of growth rate for elephants anywhere in reasonable conditions. It represents about one calf every 5 or 6 years. So that's quite a reasonable estimate for the country. Some areas obviously will have more than others. And here, this one should have gone before the other one. Sorry about that. Because we haven't done countrywide surveys every single year since 1995, we've had to do combinations to give that overall picture. So that's as far as we can get it, and those are the figures that we use to derive that upward graph. Let me just check if I have any other notes to mention there. Nope. So we'll start off with the Etosha elephants. They were practically wiped out by, in fact, they were wiped out by 1881. Not a single elephant to be found. And then in the 1950s, they started putting in boreholes and providing water, and it attracted elephants back in. And because of those waterholes, elephants were not only attracted in and are attracted in, but also they're able to survive droughts and the dry seasons. So they're able to stay there. And you can see from this graph, although these are not all comparable surveys, those are surveys that have been done in different methods. But it does show you that there were very, very few in the 1950s, which I'm not going to try and press that thing because I'll keep switching it on and off like Colin did. But look at the bottom there, 1950, there were very few elephants. And then they've been increasing gradually over the years until 1983, there was a cull. That dotted line there is a cull. I think they took off, I'll have to look this up because I'm senile. Yeah, it was 220 in 1983, and then in 1985, they took another 300. And you can see there was a dip in the numbers after that. You can see those dots are downward. Now, those surveys are not strictly comparable with the ones that we've been doing recently, which is why I haven't added them onto the trend line there. So the comparable surveys are those ones with the line through, with the confidence limits. And it's a very significant trend at 1.8% per annum. Not a very high growth rate, but it is a very arid area. Excuse me. The population now is thought to be somewhere around 2,900. I'm losing my voice. Northwest, that's a very sad story. They were hunted madly for ivory, and then from the independence war and people poaching elephants crazily up there. And they were, by the end of the 19th century, they'd been really decimated. They were kept low because of they cannot get very, very numerous because of the conditions there. It's extremely arid. It can't support high numbers. The growth rates are slow. Reproduction is much slower than anywhere else. And there's higher mortality than anywhere else because the conditions are so tough. Nevertheless, there seems to be a bit of an increase. There are very few surveys, proper scientifically comparable surveys. So there aren't enough to actually show a trend. We put a line there, but it's actually not significant. And you know that line says 3.9%, but it could be, as you can see between those red lines, it's a huge minus 1.1% to 8%, and it's not statistically significant. That last survey, 2016, the estimate was around 1,200. So that's from about 400, I think. Yeah, 400 to about 1,800. Not very many. Khaudum and Nyae know that there's not very much historical information about these animals. There probably weren't that many historically because it's a very dry area. Like across the border there's not very many animals there either. And these have probably been attracted in by boreholes. There is a large pan system, as you probably all know, in Nyae, which is attractive, but that's also not full of water all year round. So it's quite a harsh area if you don't provide water. But it has been an ideal place for them, and they have increased very significantly at nearly 5% per annum. That outlier there, you can see 2013, that was an interesting one because there was a capture going on at the same time as that survey. And it scared the elephants across the border into Botswana, so it was an undercount. So that's why we've not actually included that in the estimates for the trend. Population is now around 8,000. This is where the most elephants are. Again, there's not much history for them, but because it's part of the bigger population of it's now the Khaza, Botswana, Namibia, Zambia, and Angola, that's one big population. We assume that they were under the same pressure that was recorded in Botswana, which was overhunting for ivory up to, now let me just look this, I don't know if I've even got the figure here. Yeah, 1893, when in Botswana they started putting in controls and the population of elephants started going up. So we assume that these elephants were under the same sort of pressure as they were across the border. This is a success story. The increase is again around 5%, and the population is now around 12,000. As you all know, this Zambezi population is part of that bigger population, and you can see that they do move across the border. This is stuff from these data are from radio tracking with satellite, from MET satellite collars, I think, or GPS collars. And you can see that the animals partly live in Namibia and they move into Botswana. That straight line there across the border is a fence, and the one going directly south is also a fence. That's the northern buffalo fence, and the elephants just don't cross them, which is quite extraordinary. There are elephants in there. Okay, I think I will try this thing. There, very few elephants there, and there are a lot more here, but these are the Botswana elephants that don't cross over into Namibia. So the elephants that have been collared in Namibia are the ones that you can see on this map. They do go over fences, and I stole these photographs from a friend's Facebook page. This fence here is pretty trashed. Well, I don't know if it is now, but when I was last there, and the elephants just go over it if they feel like it. But in Botswana, the elephants are basically found all the way next to the rivers and all the way around the delta there, and in Chobe. So this is where our elephants go. That's what some of the game fences look like. That chap is actually looking at elephant spoor, apparently. That map is an enlargement of this one, which is shows the seasonal distribution of elephants in Namibia. And as you can see, the wet season, which is the blue, is much bigger range than the dry season. And it stands to reason they go where there's water. If there's no water, they're going to have to hang around near the rivers. And in the wet season, they can actually expand. And you can see they cross over into Botswana. And in Etosha, there's like, I think it's, what was it, 56% expansion from the dry season range, which is that red there and there. And in the wet season, it expands right into that. And similarly in the northwest, but not quite as much. There's a bit more range there, but they still stick to pretty well where those ephemeral rivers are. In the wet season, they go across into Angola, and they expand in the Caprivi as well. And look at that in Chobe. This is elephants from Namibia going into the Chobe. And that's basically it. These are the people who've sponsored us, and we're very grateful to them all. And some of the data came from other people, the telemetry data from WWF and MET, Nankuse, and those are the people that have actually collected the data, did all the work. We just stole it. And then some of the data came from reports that that other people have found. And if you actually want to see the reports, you can get them from the Environmental Information System, which is easily accessible on the internet. Or we've written it up and it's in pachyderm, and I can, if anyone actually wants the paper, I can give it to them. Or you can Google it and get it off the internet. And that's it. Thank you very much. Any questions for either of us? Excellent. Let's go home.
So much, dear Debbie.
Thank you. Oops, I keep doing that.
We are getting light here. Thank you so much, Debbie. Thank you so much, Colin. I think this was very, very interesting. And there you are. Any questions?
Oh, I don't know how to. Give it to you.
So I want to know, why would the elephants not cross the fence?
Can I give that to you as well? Thanks. Can you hear me on that one? Okay, I think it's because that fence is actually very well maintained, because it's a different country and they have to maintain it. I think that's the only thing. It is a very big double fence as well. So it's a sort of a game fence, and then one of those huge game, I mean, it's a sort of like a cattle fence, and then a huge game fence. And I think it's just too well maintained. Also, they don't, part of that range, they don't actually want to go across. There's nothing there. There's no water just about all year round, even in the wet season. And I don't know. I think it's a good question, but I don't know. Yeah. Any?
I'll take it to her. You have to say it so that this.
Why do the elephants congregate south of the road? Except for the two core areas, they traverse across the road in those areas, but in the central area, they're all south of the tar road.
In Botswana. In Botswana. There's not much water. They do cross the road because we've seen carcasses there. In that area there, but not very many. Yeah. And the buffalo don't either. Yeah. They do in small numbers, but there's nothing there. What would they go for? There's no water. Those tracking data are actually, they're zooming from the east to the west, I think. If you did the analysis, didn't you?
Can I chip in there? Yeah. Hello?
Just talk.
Does that work?
Yeah.
Yeah. What happened if you see those animals in Botswana? Those animals in Botswana, on the ones from Namibia that are going into Botswana, the big red patch on the other side of the Khaudum, those ones, when they go back into Namibia, they do a very, very fast movement, zoom straight across to the Okavango, and they don't spend a lot of time. So basically, they are choosing the fastest, quickest route across. But there's also a little bit, there's a couple of settlements just north of the road, and the tracking information shows them just avoiding those. You can see there's a dent there with going round. But the reason you don't have many is they're just going fast across there. They don't want to go north of the road because they want to get as fast as possible. Why do they do that? Anybody's guess.
But the other interesting thing is that here, around these parks, is where most of them hang out. And then in between, they avoid them like the plague, that area like the plague. And these movements here are also quite fast. From the safe part of the park up into the safe part of the thingy, what's it called? The name that I can't remember.
Somebody in MET needs to publish all that.
Yeah.
Because
These
there's
are
a lot
not
of
our data.
detail being lost there.
So may I ask, is the growth sustainable with the limited resources? We are an arid country. We do have humans there. Just asking, do the scientists believe that the situation is sustainable? Should there be more management? I'm not going to ask what the options are, but if we draw these lines up for the next 5 years, what will happen? We heard about the story of Botswana elephants dying. The environmentalist, the expert, had warned that there might be too many. What it's like in Namibia?
I think I'd question that about them dying in Botswana. But
Yeah, there was that. There was that dieback in the area of the panhandle there, but it wasn't that many animals.
Yeah.
We don't like to comment on that. You know, you need to ask somebody else, because we're here to count the elephants, and we're telling you where they are and how fast they're growing. Somebody needs to worry about that. But just looking at the numbers, you can't tell. Is that too many or not? You need to actually, if you're worried about it, you need to be looking at what they are doing. How badly are they stripping the resources and how long it's going to last? But it's not, we don't comment on that.
well, I do.
Debbie does.
It depends what your goals are for the area. If you're wanting to preserve vegetation, for example, then you probably don't want lots of elephants. And but if you don't care, then like Chobe has had many elephants. If I can do this thing again, for years along here, and the woodland has completely changed, and so have the mammals, the other mammals that live there. So it depends on the goals for the area, the objectives for management. If you want lots of elephants, then you leave them, and then perhaps they'll die if there's a situation that isn't good for them, but perhaps they won't.
Can I just share a comment and an anecdote? In 1974, I hitchhiked from Swaziland to the Okavango swamps, and I was in Mound Club, and a young man about my age, maybe a bit older, invited me to fly with him the next day over the swamps. He was counting elephants. Now, I was very interested in what you had, all the sophisticated technical equipment, the GPS. You said that for location, we didn't have it. I wasn't aware of anything. There was no app. We flew over the rivers. It was absolutely wonderful, but we didn't see one elephant. We were out for about 4 hours. It was absolutely superb and a magical experience. Later, I learned that guy was Ian Douglas Hamilton. So what a privilege to be able to do that. But I'm just so interested in how the techniques and the technology has changed over the years, because that was how many years ago? 45 years ago. Wonderful. So thank you very much. It was really interesting. But having had that first-hand experience of flying over, we saw lots of other things, crocodiles coming in, but no, not one elephant. So he was counting from Tanzania and counting the whole area. But what a privilege it was. So if anyone gets the opportunity to go up with you, it's just amazing. And thank you for your talk.
So I do believe there's a lot of civil society science coming in. I mentioned the Khaudum full moon game counts. It's not only elephants. They were interrupted, as I understood, because of COVID. This obviously leaves gaps in the statistics. We hope that they can go on, and I commend those that do invest their own time, their own resources to go assist. I think that only when we have the whole picture, we can take proper decisions. For now, any more questions?
Before you drown.
Please, controversy. Where's the controversy? Now, this is supposed to be controversial.
Regarding the red dots, it's mentioned it's during the dry season. The blue ones during the wet season. Am I right?
Yep.
Okay. What's the difference of the density? The red one, it's much more than in the rainy season. Where are they then?
Yeah, it's higher, but this is slightly misleading because the reds overlap the blues. I put the reds on top of the blues because that makes it obvious. But and I can't remember I think the increase in the increase in the area that these are the same animals, the red ones and the blue ones. Increase in the range is about 40%. So it's not a huge increase. So that big density of 2 per square kilometer on the Khaudum, it doesn't come down all that much.
Any more comments, questions? Comments, questions? There's another one. Duyani?
I'm interested to know how you train people to count, because to actually identify an elephant or a hippo or a warthog, you know, how accurate, and how do you train people as observers, and what makes a good observer?
Okay, first, what makes a good observer is, sorry, I'm losing my voice. Good eyesight and not getting airsick, and staying awake. So those are the 3 main criteria. It's very easy to see animals from the air. I mean, you can see hares and small animals. We even did a survey of a fish eagle eggs once. So seeing them isn't a problem. But some people, when they're new at the job, have a spatial perception problem. We had a survey in Malawi where the guy counted 30 duikers, and when we went back, those were actually eland, because he couldn't figure out the size from the air. But I mean, you train them. Colin, do you want to say it? You're waving your arms around.
Yeah, the best people are people who've worked in conservation. Game guards and game wardens and people who know what the animals look like. They pick it up very quickly and don't have a problem seeing them from the air. Just taking a raw outsider, I wouldn't like to say how long it would take to train him.
Just want to know how many elephants are sort of sessile, more or less staying in one area, and how many are constantly moving, migrating. I mean, not constantly, but migrating according to the season.
No, we don't have that figure to hand. You're right. It's a good question. They don't all move the same. They're not all as mobile. But I mean, as I say, I mean, there's that massive data set there, and it's a good job for somebody in MET to sort that out. And your question is one that they could answer.
Yeah, it's Chris Brown. Colin and Debbie, I would like to pick up on your question there, Colin. Where's the controversy? Well, in fact, there should be no controversy because the methodologies used here are well established and have been tested all over the world, in the Americas, right throughout Africa, and Kenya, Tanzania, all over. And these are standard methods and standard statistics which have been proven again and again as providing good information. The other thing that's important is that Colin and Debbie are not actually involved in the management of these species. They don't care if they're 2,000 or 20,000 in Namibia. They just care about the quality of the work, the quality of the data, the precision, the accuracy of what they're presenting. That's what they care about. So if there are 10,000 elephants tomorrow, no skin off their nose, their data is telling the story. The controversy comes where you have uninformed people who set themselves up as knowledgeable about a situation, who have a lot to say on absolutely no grounds, no evidence, no solid information whatsoever. And we allow them to have this voice. That's the problem with social media. They have this voice and they make Namibia look bad globally in the conservation world, all over, and we allow it. And that's why it's so important that scientists stand up like this and present their data, explain the methodology. You can see the precision, the amount of work that goes into it, how much effort goes into it, how much cost goes into it, and the solid scientific basis on which these things are done. So when we hear those voices, we, all of us, just say, just stop your bullshit. Stop talking this bullshit. It's not true. We know that. We've got really solid people there producing the data, and we're not going to accommodate it anymore. I think that's a really important thing that we do. Because the science in Namibia is good, the conservation in Namibia is good, the partnerships in Namibia are outstanding. There are very few countries in the world that achieve this, and yet there are voices in this country that pull it down, pull it down, pull it down all the time. And we need to put a stop to this. We really need to put a stop to it.
Thank you, Chris.
And I really, really say thank you, Dr. Chris Brown, for saying this. Thank you for exactly saying what the issue is, because they could have been here tonight. And again, no, when they have the opportunity, they are not there. You'll probably see it on the social media. Anyway, this is a fact-based presentation. I do assume that we can hand out the PowerPoint presentation with your permission. I do assume that we can hand out the recording on request. We can obviously run it through you. Fact is, yes, this is exactly it. It's transparent. The numbers are on the table. Anyone who has any more questions can happily go to the experts. They are not involved in the management. And with this, thank you so much, Debbie and Colin and Kenneth. I see you are on the Zoom. Thank you for making the numbers available, and thank you for sharing.